Yeah, it's good to be here, and I thought we'd do something a bit more sort of sciencey and dinosaur-like this morning, because if you've been listening to our radio show, which we did with Kevin all week, then you'll know we've dealt with everything from dinosaurs to creation to Noah's flood to history to archaeology and everything else. And then on Wednesday, we had a little bit of a look at history, to try and get that foundation, that understanding of where the idea of millions of years and everything like that came from. But today, we're going to have a little bit of a look into some of the more exciting side of things to do with dinosaurs and the like, and we're going to take you on some dinosaur digs around the world and see what evidence we can find. A reminder of the website's up there, and by the way, also good morning to everybody watching online. I know there's people tuning in, so it's great to have you with us as well. A reminder of our main website, creationresearch.net. Again, if you're not able to be with us today, or if you have questions or want to find out more about the research that we do, there are Q&A sites on there, there are research reports on there, and as we've already mentioned before, we have creation conversations every week on our YouTube channel, where you can get an opportunity to come in live and ask questions every single week. We deal with a different topic every week, and we really delve down into the deep things, and not just creation, not just fossils, but also some of the more social things that are going on today. Like, for instance, a program we put out a little while back, What is a Woman? Now, that can be a fairly controversial question to ask nowadays, but we happen to have a medical biologist on the team, so certainly qualified to comment on it from a biological perspective. She also happens to identify as a woman, so we got her to answer the question, and it was a really good program as well. So do go and check out Creation Conversations and find out about the work that we're doing. It's also available on podcasts and everything else as well. Now, we mentioned before the museums project that we have, both in the UK and around the world. We have 5 museums that are now being developed or are in development. We have hundreds of thousands of fossils and artifacts from all over the world in these museums, where you can come and explore, you can get up close and personal, you can come round for a guided tour, and yes, you do get to see dinosaurs as well. Well, we've actually brought a collection, or a selection rather, of our collection here with us today, which you can go and see out in the foyer there, including this rather brand new one. Well, there's Dr. Glenn Wilson, the Dirt Doc, holding a rather spectacular fossil. This is temporarily with our US museum collection. It will eventually go on to the rightful owner, who's actually based in Tasmania, but he wanted it to come to us first to be looked after for safekeeping while we work out how to get it to him. He runs our museum down in Tasmania in Australia. But what is it? Well, you're probably able to recognize it fairly easily. Now, you're able to recognize it fairly easily because we still have them alive today. These are what we call living fossils. It is indeed a dragonfly. Oh, Jurassic dragonfly, named after the rocks in the Jura Mountains. In fact, these are from the Jura Mountains, from the Solnhofen in Germany. So this is a German fossil that came all the way over to the United States, and eventually it'll make its way all the way over to Australia. But it is a Jurassic dragonfly. And you recognize that it's a dragonfly because it's a living fossil. We still have them alive today. And in fact, the person who invented the term living fossil was Charles Darwin himself. And he wrote about it in his book, his famous book, On the Origin of Species. And he said, these anomalous forms, they seem to have existed to the present day. They could be called the living fossils. That's what he said. He came up with the term. And he said they ought to be anomalies. And yet he also recognized that it was one of the biggest problems with his theory of evolution was that you couldn't really see it in the rocks, because most of what you find in the rocks are these things, living fossils, even though according to his own theory they ought to be anomalies. Now, he predicted that in 60 to 100 years' time there would be vast amounts of evidence shown in the fossil record. Well, we're 150, nearly 200 years on from that time, and it still hasn't turned up as of yet. So they keep looking, and we keep collecting and keep putting evidence like this on display. You do find change in the fossil record, by the way. Let me give you an example of that. This was actually a display which was up in the Houston Museum of Natural Science, which I visited right at the beginning of this trip. When I first came here, the first thing I did way back on the 2nd of June is I flew down to Houston to present a paper at an academic conference on finding soft, squidgy stuff inside very, very old bones. Stuff that really shouldn't be there if they are of that age. But while I was down in Houston, I went and visited the Houston Museum of Natural Science, and they had one of these. Now, this is a cast. It's not the original. We do have the original. It's actually on display in our Australian museum, Jurassic Ark, but it's from Texas. It's from the Texas redbeds. It's called a metoposaur. And we know what it is because we have a modern-day living example. There's one fairly major difference between the modern-day living example and this fossil example, and that is, as you can see, it's rather a lot smaller. Now, on the right-hand side, you can see the modern-day giant Chinese salamander. Now, this is a pretty big salamander by today's standards. It's known as the giant Chinese salamander. It can actually get almost up to 5 to 6 feet long. It's pretty sizable, but it is tiny compared to the extinct version. Now, you realize that these are identical in every other way apart from size. You see, what has happened is there has definitely been change, but the change is not actually evolution. The change is exactly the opposite of evolution. It's devolution. They have devolved. They've actually gone downhill. They used to be big. They've lost that ability, now they're small. There's the actual diagrams of it. You can see a human being, the average human. You can also see next to the average human size is the size that most salamanders are. I've caught salamanders all around Tennessee. They're tiny little things, right? And yet then you have next to that the Chinese giant salamander compared to the fossil giant salamander. Now this is a history of not evolution, it's a history of devolution. It's a loss of information. It's good to bad to worse. And the big thing that we do when we bring these fossils around, when we put these things on display, when we do these presentations, the big thing which we're trying to get across to people is that Scripture teaches both in the Old and the New Testament that all things were made by Jesus Christ. As it says in Colossians 1:16, not only were all things made by Christ, they were made for Jesus Christ, and it's in Jesus Christ that all things are held together. All things consist in Jesus Christ. So do check out the museum websites, which we have a network going all around the world. You can support the Global Museum Ministry and also sign up to our newsletter, which there are sign-up sheets outside there, aren't there, Glenn? Which you can sign up and follow the work of creation research all over the globe. Okay, our main topic for today is going to be dinosaurs. We're going to delve into both the science, we're going to delve into the Bible, we're going to see if we can get a bit of a bigger perspective that you might normally get. Starting with another Bible verse, let this mind be in you that was also in Christ. You see, let me give you a little bit of perspective here. When just before I was born actually, my dad was an atheist. He didn't believe in God, hated God, would often debate and get into arguments about God, hated any thought of there being a supreme being. And when he married Mum was a very young Christian, had just become a Christian, very immature, and she decided that it was her goal, her mission in life was to make Dad a Christian. Now, she hadn't quite got to the great big idea of what salvation was, and and that there's not really a lot that she could do about it other than continue to give him the gospel. But she was determined she was going to be the one to make him a Christian, so she drilled a huge amount of apologetics into him, day after day after day, really making him quite frustrated. Well, there's a rather wonderful testimony story that comes out of this, because Dad was actually in work at one day and he realized that some of his colleagues were having a conversation about Jesus, and they called him over and said, "Oh, Ryan, you don't like God or Jesus, what do you think? Do you believe in Jesus?" And in his own words, he said, I opened my mouth to mock, but instead what came out was, yes, I do believe in Jesus, let me tell you why. And out came all the apologetics arguments that Mum had been drilling into him over the last year of their marriage. So it's a wonderful story, but the point of it is this. After he had finished this conversation and went and sort of broke down in the bathroom and gave his life to Christ, on the drive home, the first question that he had was, what am I now going to do about the dinosaurs? Because a big part of why he had been rejecting the idea of the Bible and God and Jesus and all this stuff was, well, science has disproven it. Science has got rid of the Bible. Dinosaurs lived millions of years ago, and that doesn't fit into the Bible at all. And so when he started going to church with Mum, this was the first question that he had. And he went to one of the elders of the church and he said, what do we do about the dinosaurs? And the elder of the church said, well, dinosaurs have great big horns on their head. They've got horrible, vicious teeth. They love to kill things. Now, I suspect that he was getting his idea of dinosaurs mostly from Hollywood, but his logic was, I don't think that God would create something like this. I think that Satan created the dinosaurs. The devil created the dinosaurs. Now, we might sit in that and go, how on earth do you come to that conclusion? But it's not actually a unique conclusion. It's one that I've come across many, many times, where this idea that dinosaurs were horrible, vicious creatures that must have been created by an evil, demonic being. So I was just born at that time, so for 4 years of my life I was banned from having anything to do with dinosaurs. I used to come home, this is sort of in the 90s, right? You come home with little party bags after your friend's party and it'd have little models of dinosaurs in it and they would disappear overnight and I would never know where they went. I've been taking revenge ever since because I now dig the things up, but it does give you a bit of a perspective as to many people's, particularly Christians' opinion of these dinosaurs. Many people are scared of them. Many people don't understand or can't really fit together this idea of what we understand about dinosaurs in books, in museums, in literature, and let's face it, even in Hollywood films, it does affect the way that we view these creatures, and they struggle to marry that up to what we read in the Bible. Okay, so coming from this perspective, thankfully my parents started to find speakers like what I do now and get some answers, and some of the original creation magazines, which were started by John Mackay many, many years ago, began to get them some answers to some of these questions. But the thing that we came to realize very quickly is the only way you're actually going to get answers is if we start with this. Let this mind be in you that is also in Christ. We need to start thinking things the way that God does. So let's start by getting a biblical perspective. In the beginning, God created. Genesis 1 verse 1. Right there in the beginning, God created. God created all things in 6 days, and 10 times in Genesis chapter 1, it says that God made each creature, each living thing to reproduce after its own kind. So don't be surprised that we find fossil dragonflies that are supposedly 150 million years old, and yet they're still alive today because they've only been doing what God has told them to do, which is reproduce after their own kind. Get to the end of Genesis chapter 1 and you find that not only has God made man in his own image, in his perfect image, but God created the world very good. Now you and I view the word good as a moral term today, generally speaking. And it is a moral term, but it's so much more than that because God actually described what he meant by very good. By very good, he meant that all creatures were vegetarian. Genesis chapter 1 verse 30. You can read it there. All creatures were vegetarian. And in fact, Adam and Eve were naked. They had no clothes on, yet they weren't getting sunburnt and getting cancer from the harsh sun, and they weren't freezing to death at night. So not only was the world very good, the climate was very good as well. Skip forward to Genesis chapter 3, and you find that man sins. God curses the ground, and death enters the world. And the world has changed from good to bad. By the time that you get down to Noah's flood, the Bible says that the intent of man's heart was only evil continually, and so God judged the sin of the world in a global flood. Then at the end of the flood, you have the first ever reference to climate change in the Bible. For as long as the earth shall remain, there will be seed time, harvest, summer, winter, cold, and heat. Erratic climates, climates that are difficult to survive in, and you find that the world had changed from good to bad to worse. You see, this is the picture of history according to the Bible, from good to bad to worse, which, by the way, is the opposite of what it teaches in secular science when you read about the theory of evolution, which says we started down here as slime, and over millions of years we evolved onwards and upwards until we got to where we are today. And this idea that we are continuing to evolve. So we need to keep the biblical picture in mind as we investigate the world of dinosaurs. So let's take you to the United Kingdom. That's where I'm from. And we're going to take you down towards Bristol. That's where the arrow is pointing. And at Bristol, just south of Bristol, there's a huge bridge which connects England and Wales. It saves you about 200 miles of a round journey. So there's a big bridge, and millions of people pass over that bridge every single year. And yet very few of them realise that what they are driving over are dinosaurs, because this is the cliffs underneath the bridge. You see the big red rocks, you see the grey rocks, you see that lovely straight line? Geologists love straight lines because it makes it so much easier for drawing maps. Working where the straight line begins is easy. Working where the deposit underneath or on top finishes is a little bit more difficult. But in that red rock, you find things like this. Can you see the bone? The big curved rib bone? This is a dinosaur bone. Here's another one. You see the big black bone with all the internal honeycomb structure in it? This is one of those big plesiosaurs, the big swimming dinosaurs, the big marine reptiles. And it's not just things like bone that you can find. Can you see the footprints where the arrows are pointing? This was actually donated to us by the quarryman who actually went and dug this up and found it. He thought it was a human footprint. We looked it up and we found out that it's actually one of those flying reptile footprints. Pretty spectacular stuff. This kind of creature here, right, often referred to as the flying dinosaurs. Well, this is from the Purbeck limestone, which is in the South UK coast. And it took us a few years to work out exactly what it was by asking around different people and visiting different museums. It turns out that there's been a total of 3 of these footprints found. One is in the Dorchester Museum, which is the main county museum. The other one is in the Natural History Museum, which is the big museum in the UK, in London, and we have the 3rd one. And so you can come and visit our museum in the UK if you ever visit the Creation Research Centre, and you can see it up on display on the wall. Now, it's not just the south coast that's really good for fossils and for dinosaurs. The 6th best place in the world for diversity of dinosaurs is actually the Isle of Wight, and not many people know that. So if you ever do come to the UK, try and join one of our fossil hunts or our conventions, because we take you to places like the Isle of Wight where you can see the beautiful rock layers. This is called the Weald. And in the Weald, you can find some pretty amazing dinosaurs. Now, we don't get you to do this, but this is the first ever dig that I did as part of my undergraduate degree, which you have to sort of climb up onto the side of the cliff, sometimes with harnesses and everything else on, to see if you can find any dinosaurs. But this is actually one that we found on one of our field trips. What is it? Getting a little bit closer. Can you see the bone there? This is actually the back of a dinosaur skull. So we started excavating it. Now, one of the downsides of living on a relatively small island, and actually your best dinosaur fossils being found on an even smaller island, is that you are relatively governed by tides, because most of your fossil hunting locations are on the coast. And of course you have 2 tides a day, and then you're busy digging through your fossil and you realise that the tide is about to come up to your waist, so you have to try and quickly get back to dry land. And that does mean that the next available time to go and dig up your fossil is in the middle of the night. So that's why we find ourselves at 3 o'clock in the morning down on the beach going to dig up dinosaur fossils. But the results can be pretty spectacular. Now, you don't have to do things like that if you come on our field trips. Just lying around on the beach, you can find fabulous footprints. Now, as we travel around the UK and as we travel around the United States and Australia and Germany, and you find these fossils all over the world, there are some questions to be asked. Questions like, how do dinosaur fossils form? What evidence do they show? Do they show evidence of millions of years and a slow burial, or do they show evidence of a quick flood burial? Now, these are some questions that should be asked as we travel around and dig things up. As we go to Morocco and we excavate this fabulous mosasaur jaw, these are the kind of questions we need to be asking. So let's delve in a little bit deeper. Starting with these footprints here. You recognize them? Dinosaur footprints. Brilliant dinosaur footprints. Now, one of the big questions we get asked all the time, and by the way, will be available for question and answer afterwards, but one of the questions that we get asked all the time is, how did dinosaurs fit onto Noah's Ark? If there really was a Noah's Ark, if there really was a global flood, if God really did send Noah 2 of every land animal to go onto the Ark, or 7 of every clean land animal to go onto the Ark, then how did Noah fit dinosaurs in the Ark? Well, we like to bring these dinosaur footprints up because we actually took a cast of these footprints and we in fact sell them around the world. There it is there. It's a baby dinosaur. Now, it is very cute, but it also makes an important point. The largest dinosaurs of all were the titanosaurs, the ones with the great big long necks, right? Well, this is a paper that was published a few years ago about the discovery of tiny dinosaurs. Baby ones, young ones. And they actually made the point that, look, there's your titanosaur in the middle, enormous great big creature. There's your human on the right-hand side, average size, but then far over on the left, you've actually got your baby titanosaurs. And it makes sense because the largest egg that we've ever found in the world was about this size. And it wasn't even a dinosaur egg. It was a bird's egg. The biggest dinosaur egg we've ever found is about that size. Not much bigger than a sort of, football, one of your American football sort of sized, and shape actually, interestingly enough. But, Noah would have easily been able to fit the dinosaurs on the Ark. No problem at all. You take the juvenile ones. You see, the point which we make over and over again is it is not the evidence which contradicts the word of God, it's simply the opinions of men and the way that people interpret the evidence. So the real question to be asked is, who is your authority? Is it God's unchanging word, or is it man's continually evolving theories? All right, let's ask this question then. How did the dinosaurs get into the rocks? Because that's how we know about dinosaurs. We can go and dig up their fossils. You can come on a fossil dig with us. There's some great stuff around. Okay, well, let's go to a children's book. And let's see what they teach in a children's book about how an animal can become a fossil. Here is your standard story. The animal dies and sinks to the bottom of the sea. It is covered by sediment. The soft body dissolves, leaving a mold, and if the mold fills up with sediment, it becomes a cast, and the earth moves and brings the fossil to the surface, and the land erodes, and eventually you can find a fossil. Now, there's a lot of information wrong with this. For starters, the idea that the fossils that we find are only casts is nonsense, quite frankly. The fossils that we find, the dinosaur fossils, are the actual bones of the dinosaurs. They have not been turned to stone. They are not a cast. They are the actual bones of the dinosaurs which have become permineralized. That means permeated with minerals, filled up with minerals. Now, bone is very, very porous. It's got the big honeycomb structure in the center. Even the densest part of the bone, where you have all the bone cells, the osteocytes, even the densest part of the bone is still very porous. And so minerals can seep in and can permineralize it, leaving the original bone still there. But before we even get onto some of the technical detail, let's just ask this question. What is a 20-ton, 40, 50-foot tall dinosaur, land dinosaur, doing at the bottom of the sea? Now, you do have to ask this question because the reality is that most of these dinosaurs have plenty of evidence that they did get buried in the sea. So how do you get an enormous dinosaur out in the middle of the sea? You see, they're not answering this question. Well, here's a slightly more technical diagram from a museum, the Natural History Museum in London. Dinosaur collapses and dies. Poor Mr. Dinosaur. Flesh rots away and the bones remain. The water level rises and the sediment buries the bones and the footprints, and gradually the bones begin to fossilize, and then eventually erosion means that you can dig them up. And you see the big time arrow? You see, the point which is made over and over again when you visit museums, when you read books about dinosaurs, when you look at textbooks, is that fossilization from creature to fossil is a very slow process. This is what is taught. But another Bible verse is applicable here. 1 Thessalonians 5:21, test all things, hold fast to what is good. So you have an idea, you make an observation, you test it, you throw it out things that are bad, you keep on things that are good. Now this is a good summary, if you like, of the scientific method. You test all things. Now, it just so happens that this isn't in a science textbook, nor is it the scientific method. It's actually a commandment that God has given us to do. So let's do some testing. Let's take you a little bit closer to home. Let's take you to the southern Alberta Badlands. In fact, before that, this is actually from the National Dinosaur Monument in Montana. It's a Camarasaurus. Now, it's one of those long-necked dinosaurs. Can you see its neck is thrown up? Its tail is thrown behind it. Its legs are a little bit squashed. Here's another one from the national parks in Montana. It's a funny position. Well, let's go a little bit further north to the southern Alberta Badlands, and let's have a look at their dinosaurs in Canada. Hey, look at the tail. Look at the neck. Look at the legs. In fact, here's another one from the same location. Look at the neck on that, thrown backwards, tail arched up over its back, legs bent up underneath. Here's a Gorosaurus from the same location. I mean, some of this stuff is just remarkable. Interesting. Now, what is going on with the dinosaurs here at Alberta in the Badlands and also in Montana? Because it's important to realize that when you go round places like the Houston Museum of Natural History, or you go round places like the London Natural History Museum, and you see reconstructions of dinosaurs and they're doing a sort of a nice pose like this, that's not actually how you find them, right? That's an old Victorian concept of, we've dug up these bones, let's glue them back together in the way that they were when they were alive. And nowadays, I have to say, going around places like the Houston Museum of Natural Science, enormous place, you go around their paleontology thing, 90% of the fossils are not real. They are casts. They are reconstructions. They are models that have been put back together to look like they are interpreted to look like when they were alive. This is how you find dinosaur fossils. Over 80% of complete or partially complete dinosaur fossils have evidence of being in this position. But it's not just from the United States. Let's take you back to the Jurassic Coast. We had a fabulous convention at the Jurassic Coast last year. Lord willing, we'll be holding it again next year. 5 days down on the beach where we dug up fossils. We had workshops and seminars. It'd be wonderful to do something like that over here one day. But the Jurassic Coast is quite famous. It's where these dinosaurs were first discovered. And this is the most famous dinosaur from the south coast, Scelidosaurus. And this is a plaque in the Heritage Centre, the main museum down there. And here's a photo of the plaque. There's the fossil. Now, I don't know about you, but that looks like a squashed dinosaur. His neck is thrown up, his legs are squashed up underneath. Now, they don't like you taking photos in the Heritage Centre, so we had to go and find the original finder of this dinosaur and get his permission to go and take photos, which he agreed to let us do. So here's the original finder's hand pointing out something rather interesting at the Scelidosaurus, his fossil that he found. What is it? Well, there's actually still food in its throat. Now, you can tell whether this food is on its way down or whether it's on its way back up based on how digested it is, right? Based on how fuzzy it is. Now, if you follow that throat down into the stomach, you can actually find there's still food in the stomach as well. So this is a vomiting dinosaur. So this dinosaur has been squashed. It has food in its throat, vomit that's coming up, it's been fully squashed, and it's buried with seashells, deep sea creatures. You see, all the evidence points to the fact that this dinosaur drowned. Because of a very simple concept, if you find land creatures and seashells and plants all buried together, it equals a flood. You see, second-year geology, I was taught that what you do is you go and you look at a rock deposit, you look at the fossils that are inside it, and you interpret it based on an ecosystem that is represented by those fossils. So if you go and it's all shallow marine creatures, then it's a shallow marine environment. If it's all deep sea creatures, then it's a deep sea environment. If it's all terrestrial tropical creatures, it's a terrestrial tropical environment. But the reality is, when you actually go and dig up the rocks, you don't find it quite as simple as that. And we have examples of them just out here. I brought some from the UK, where you have the deep sea creatures buried next to the land plants, where you have the dinosaurs buried next to seashells. In fact, I always remember, I've been digging up fossils at a place called Hunstanton. We showed a video just before this session about Hunstanton, and it's available to watch on our YouTube channel, so go and check it out there. But I've been collecting fossils from Hunstanton for years. It's on the Norfolk coast in England, and I got taken to Hunstanton as a student, as a geology student, having previously dug there. And the professor leading it said to me, we know that Hunstanton is a shallow marine deposit because all the fossils here are shallow marine creatures. And I said, excuse me, Professor, what about the fossil trees here? He said, there aren't any fossil trees here. I said, yes, there are. Let me show you. Come over here. Oh, look, fossil trees. He said, I've never heard of this before. I said, well, I know that it's known about because if you go to the Sedgwick Museum, which was founded by Adam Sedgwick back in the 1800s, he has examples of the fossil trees from Hunstanton. He said, I never heard of that. I said, so how are you going to interpret Hunstanton now, seeing as there's trees and sea creatures buried together? He said, I don't know, I'm going to have to think about that. Well, anyway, he went off. I never heard anything again from him. But what was interesting is that I happened to be in a Facebook group at the time for that year, geology students, and I was still on that Facebook group a year later when I'd moved on to do paleobiology, and I noticed that the same professor was leading a field trip with the next year's lot of students to Hunstanton. And after the field trip had happened, I put a post up saying, did the professor happen to mention the trees at Hunstanton? They said, no. He said that it was a complete marine deposit. Well, interpret that how you will, but the reality is when you go and dig up these fossils, and by the way, you don't just have to trust my word on this, we have the evidence, and you can even come out and dig them up with me. We can go to Spencer, not too far away from here, and we can see the polystrate trees, we can see the beautiful ferns buried next to horseshoe crabs, buried next to sea creatures and seashells. You can come on a field trip and see this kind of stuff. When you have land creatures, seashells, and plants all mixed together, you're looking for evidence of a flood. Because as I've always said, a flood is water where water shouldn't be. If you have a flood on your kitchen, it's because the water is on the floor and it belongs in the sink. So we're looking for evidence of flooding. Land creatures, seashells, and plants together equals a flood. Now you find that these Jurassic flood deposits go all the way up the United Kingdom. You can trace them all up into Scotland, and you can recognize the evidence of flooding in rocks in the United Kingdom. Oh, and by the way, the Jurassic rocks are the same rocks that are found in Germany, where our fossil dragonfly comes from. So the flood didn't just cover the United Kingdom, it also covered most of Europe. Oh, but the Jurassic rocks are also found all down throughout Asia. They're found in Australia. We have a museum called Jurassic Ark because it is full of Jurassic rocks. And you find Jurassic rocks here in the States as well. This is a worldwide flood for sure. All right, well, let's take you onto the Isle of Wight, that island off the south coast, where you can find dinosaur bones like this fabulous vertebrae and big dinosaur footprints. And there was a very famous iguanodon, which was the first dinosaur actually to be discovered. And it was a famous dinosaur that was dug up from the Isle of Wight a few years back. It's on display in the Dinosaur Museum, the main dinosaur museum on the Isle of Wight. Well, let's point out some stuff for you. There's the head at the top there. There's the neck. And the body is sprawled out over to the left. In fact, there's their diagram of it. Hey, look. Neck bent back, tail bent up, legs sprawled out. This dinosaur in the Isle of Wight is in the same kind of drowned pose that you find in the Jurassic rocks in Lyme Regis. It's the same pose that you find over in Alberta, in the Badlands. It's the same pose that you find in the Dinosaur National Monument part around Montana and Hells Creek and all that kind of place. So what is actually going on with these dinosaurs? Well, New Scientist is a sort of layman's scientific magazine which takes a lot of technical papers and information and puts it into a sort of a more understandable kind of language. And this has been published many times. research on this pose, including in the journal Nature, and this is what the New Scientist had to say about it. These dinosaurs are found with their head and their neck bent backwards and their tail arched over their back. Immersion in water is the simplest explanation. In other words, the dino death pose, as it has become to be known as, equals drowned. Well, let's stick to the Isle of Wight for a minute, because this hit the news, the media, about a year ago. There was a new dinosaur found, Vector venata. And it was found at a place called Shanklin. And the big newspapers that published on it said, this is so unusual. Well, why is it unusual? Because look at who it was found with. It was found mixed with fossil oyster shells. This is in the main museum there, reporting on it, by the way, and here's what they had to say about this dinosaur. This is the information which we're interested in. Look at what it says. The rocks in the area are known to have been formed in a shallow shore environment. So land-dwelling animals such as dinosaurs are unlikely to be found. What else did they say happened? It was caught in a flood and washed out to sea. In fact, here's the actual artwork from the museum showing you the drowned dinosaur with sea creatures being buried. Oh, but it's not just in the United States. It's not just in Canada. It's not just in the United Kingdom. It's also in Germany, from the same place where we have our fossil dragonfly out there. It's also from Italy. It's also from Nigeria in Africa. Look at the curvature on that spine. Yeah, and as I pointed out, no matter where you go around the world, where you find dinosaur fossils, you find these bent positions. And you remember what New Scientist said? Immersion in water is the simplest explanation. These dinosaurs drowned, for sure. All right, well, let's look at one more example. Daspletosaurus in Canada. There it is on display. Death pose, neck bent backwards, tail in the air, legs bent underneath. Here's the museum display sign. Daspletosaurus was a large carnivore with powerful jaws. It exhibits this classic death pose. It became so common and so well known it even got its own name, the Dino death pose. With the neck pulled over its body, the tail arched forward, the hind limbs tightly flexed. This pose is common amongst the dinosaurs and is an indication of a central nervous system trauma related to drowning. Now there's some dinosaurs drowning. And you might think this is an image that I've got one of our artists to draw up of dinosaurs drowning in Noah's flood. No, this is actually from Dinosaur Provincial Park. By no means a friend of the Bible or a friend of creation or Noah's flood, but even they can't deny the overwhelming evidence that these dinosaurs drowned. Now, you'll find that the dinosaurs come from the same rock layers around the world. They come from the Triassic, the Jurassic, and the Cretaceous. They're found in the same rock layers. These rock layers go all over the world, and they all contain drowned dinosaurs. And the dinosaurs are buried next to fish, and they're buried next to deep-sea creatures, and they're buried next to boulders that have been rolled smooth by moving water. These have been drowned, and they've been drowned and buried real quick. How do we know that they've been buried real quick? Well, it's simple. Research has shown that these dinosaurs had to be buried within 3 minutes, or they would revert back to their natural pose. Now, do you remember what they said there about it being a central nervous system trauma? A bit more of an explanation. When you're drowning, generally speaking, the reason that you drown is not because your water has filled your lungs, because your body isn't that silly. Your body will basically stop any water from coming in, so you're effectively suffocating, you're asphyxiating yourself to death. But just before you drown, just before you die, as a final resort, your body, in fact, all living creatures will do this, it's a natural reflex, you go, and your back will be arched, your legs will be bent. If you have a tail, it'll be bent up over your back. If you have a long neck, it'll be thrown back, and your mouth will be open to try and get that off. It's a shock of electricity that blasts down through your nervous system, through your spinal cord, to get you to... Okay, what's the significance of that? Well, that is a tensing of muscles. Your muscles tense. Once you're dead, you have no control over your muscles. So within 3 minutes, your muscles begin to relax, your head flops forward, your tail goes down, your legs go down, and you don't look like a drowned dinosaur anymore. You have about another 30 minutes before what's known as rigor mortis sets in, which is when the blood drains to one side of the body and you go stiff. By the way, as a side note, I worked as a zookeeper for 6 years and ended up being qualified to the highest point in the United Kingdom for a zookeeper, so I've had a lot of experience with dead animals. It's not all that pleasant, but I'm really grateful that the Lord has led me into the zookeeping world, because it gives you a big perspective on how these creatures die and how they behave. And the one thing you know is that you have 3 minutes to bury it in that position, otherwise you won't be in that position anymore. So these dinosaurs have drowned. They've been found buried in water. They've been found buried and fossilized very rapidly, and they've been found all over the world. And remember what I mentioned earlier, these are not casts, these are not molds, these bones have not been turned to stone, they are the actual bone itself. They have been permineralized, permeated with minerals. That's why when you hold a dinosaur bone, you are actually holding the bone that was inside the dinosaur. It has been permeated and filled with minerals. Interesting stuff. But the fact that you have dinosaurs which have been buried in water, been buried very rapidly, are found with fish and land plants, and are found all over the world, is starting to sound a little bit like a global flood described in the Bible. So note very well, it's not the evidence which contradicts the word of God, it's the opinions of men. You see, fossilization has got absolutely nothing to do with time, but everything to do with a process. That's the real key here. You see, and it's not a case of get the right process, it happens quickly, get the wrong process, it takes millions of years, because time is your biggest enemy when it comes to making fossils. Time will destroy your organism long before you have a chance to fossilize it. If you want to make a fossil, you need the right process, and that process needs to be quick. Well, to begin to finish up, what I'm going to do is talk about a fairly new area of science. In fact, it's so new, I am the second person who is doing a PhD, a doctorate in this area of science, so that's kind of how new it is. But even so, it's still relatively new in the wider thing. It's the question of paleobiochemistry. Big, long technical word, let's break it down. Paleofossils. Technically, it refers to old. So it's old fossils. Bio, as in biology, life. Chemistry, how chemicals interact and work together. So biochemistry is how chemicals work together for life. Things like cells, things like proteins, amino acids, how they interact with each other. That's what biochemistry is. So paleobiochemistry is looking at soft, squidgy things, cells, proteins that are in old fossils. It's as simple as that. Well, what we're going to do is we're going to look through some different reports of these dinosaur cells and fibers in ancient bones, and talk a little bit about the implications of finding these. Okay, some quotes. Fibers and cellular structures preserved in 75-million-year-old dinosaur specimens, published in Nature Communications in 2015. This is a technical scientific paper, by the way. Now, as I will tell you, and as Dr. Glenn will tell you, and any other scientist who's honest, often when we write these technical scientific publications, we will like to overcomplicate things. And we put great big long huge names and words, and well, we're going to try and break some of these down and make them a little bit simpler for you. This is what they had to say. They used a scanning electron microscope to study dinosaur bones from the Dinosaur Park Formation in Alberta. These bones were collected in the early 20th century and were held in the Natural History Museum in London in the UK. There's your theropod claws. There were some ribs from an unknown species. So what was found? Well, in the theropod claw, you had astrocyte-like structures. In the hadrosaur leg and foot, you had fibrous structures and carbon-rich material. You had the same in the ceratopsid bone, and you had collagen-like fibers in the unknown species. So really, in the theropod claw and in the ceratopsid bone, you're dealing with red blood cells. It's just a technical word for red blood cells. Collagen is a fibrous protein which is a key component of bone material. So what are theropods? Well, they're the bipedal dinosaurs with the clawed front limbs. The hadrosauruses are the duck-billed dinosaurs. The ceratopsids are the horned dinosaurs. That's literally what ceratops means, horny head, right? And if you have a triceratops, how many horns do you think would be on its head? 3, right? Big, long technical name. Let's break it down. So what do they actually say about their finds? It has long been accepted that protein molecules decay in relatively short periods of time and cannot be preserved for longer than 4 million years. That is actually out of date, by the way, because in 2019, another paper was published by the world's leading archaeological expert who said that given all that we know from our current understanding of biochemistry, in 1 million years, there would be less than 1% chance of having any collagen or any soft material present. Okay. Therefore, they say, even in cases where organic material is preserved, it's generally accepted that only parts of original proteins are preserved and that the full tertiary or quaternary structure has been lost. So what did they find? Structures resembling calcified collagen fibers, soft, squidgy stuff in bones, structures enriched in carbon, carbon equals organic, equals original biomolecule, structures that resemble red blood cells. Well, here's the scanning electron microscope images. There's the fibers found in a dinosaur rib. And you see B, which is the scanning electron microscope scan of the fibers found in the dinosaur rib, supposedly what, 75 million years old? And then below that are collagen fibers from a modern animal. They're pretty similar, aren't they? What was in the theropod claw? Well, you find this carbon-rich material and the blood cell-type structures. In the rib fibers, you have this fibrous material. Okay, well, let's compare dinosaur blood cells. There's the dinosaur rib on the left-hand side. On the right-hand side, you have blood cells from modern bone. You see, you realize that what they've pointed out, according to this paper, 4 million years is the maximum. According to more recent papers, 1 million years is the maximum. And yet we're looking in bones that are supposedly 75 plus million years, and we're finding fresh, squidgy material. Interesting. So beware of false science, as Paul says to Timothy. It will lead you astray. And make sure that you test all things and hold fast to what is good. Interesting stuff. You see, the reality is the biggest challenge to the idea that these bones and dinosaurs are millions of years old is that it goes directly against all that we know about modern biomaterial. The fact that it simply cannot last for millions of years. I mean, think about it. What is collagen? Collagen is a protein. Protein is a meat. Now, if you leave your meat out in the sun all day, how long is it going to last? Not very long, right? The decay rate is going to be pretty quick. So what could you do to slow the decay rate down? To extend the shelf life of your meat? Stick it in the fridge. Now, that would expand the shelf life from a few hours to a few days. What else could we do to extend it? Put it in the freezer. Freeze it. That would extend it to a few months, maybe a couple of years. But they're still going to decay. Still going to break down. There's still going to be a point where you're not happy to eat that meat. So what else could we do? What's a way that we could really preserve it? We could salt it. What's salting beef? Permineralization. You're permeating the beef with minerals, right? The mineral being salt. Now, it turns out that permineralization is one of the best ways to actually preserve your meat. But the reality is, even with permineralizing your meat, it is still going to have a shelf life. Because as they said, the furthest we can possibly think, based on our current knowledge, that this soft, squidgy stuff, this meat could last, is up to 1 million years, debated up to 4 million years. Certainly not 75 plus million years. It would be akin to having a cup of coffee, in the little polystyrene cups that you have out there, and asking it to stay nice and hot and fresh for a week. It just does not work. All right, let's take one step forward and talk about the concept of dino to bird evolution before we wrap up. Natural History Museum in London. The gradual evolutionary change, they say, from fast-running, ground-dwelling bipedal theropods, that's small-running dinosaurs, to small flying winged birds, started, when was that? 160 million years ago. Now, this is the idea that dinosaurs evolved into birds. It's an idea that was put forward fairly early on, only 2 years after the publishing of Charles Darwin's book on the origin of species. Darwin's bulldog, Thomas Huxley, who's really credited for promoting Darwin's ideas, he argued that based off of dinosaur skeletons compared to bird skeletons, you could see that dinosaurs had evolved into birds. Now, this is a modern quote from the Natural History Museum, which said that this evolutionary change, the start of turning dinosaurs into birds, started at 160 million years ago. Now, here's National Geographic with a beautiful diagram. Look at that. From dinosaurs to birds. The path to birds. Look at that wonderful progression as it goes across the screen, as you get dinosaurs which begin to develop feathers, which begin to develop into running birds, which develop into the modern birds. It's a lovely, beautiful diagram. Oh, and guess what? All of those fossils are based off of real fossils. Wow, look at the evidence for dino to bird evolution. Well, test everything. Let's add some dates. There's the dates. Right over on the far left-hand side, what have we got? 122 million years. Then we have 71 million years. Hang on a minute. Then we have 94. Then we have 125. Then we have 100. Hang on a minute. This is all out of order. The dates don't line up. Even by the secular, evolutionary, millions of years dates, even the dates don't line up. Okay, well, let's draw some lines. Let's put the dates in order. Oh, hang on a minute. That's a mess, isn't it? Okay, well, let's take this diagram. Let's chop it up. Let's take all of these dinosaurs, let's chop them up, and let's put them in a nice sequence according to the dates. That's what it looks like. Okay, that's a bit all over the place, really, isn't it? There's 159, which is the oldest out of these, or supposedly the oldest out of these fossils, and 2.6 million years over on the far right-hand side. But look at the gaps, by the way. There's 26 million years between the first two. There's 5 million years, 1 million years. Then there's 28 million years. Then there's 88 million years between a complete dinosaur and modern birds. Not only are they out of sync, they're all over the place. In fact, there it is, put into order and also put into perspective of the timings. I mean, it just doesn't make any sense at all. Oh, and by the way, move forward one more point. Can you see what creature we start with? The oldest creature? Archaeopteryx. Archaeopteryx was a famous fossil that was found from the Solnhofen, the same place that we have our Jurassic dragonfly out there. And look what they say. Remember what the Natural History Museum said? That the evolution of dinosaurs to birds started at 160 million years ago. Well, Archaeopteryx, a fully functioning bird, and yes, it is a fully functioning bird, even though it was interpreted for many years as a transitional form, the secular Natural History Museum in London did internal scans of its brain and its lung capacity and determined that everything matched up to being a bird. So even by secular science, Archaeopteryx is a fully functioning bird. So Archaeopteryx, a fully functioning bird, is dated at what? 159 million years old. This means that according to their own logic, dinosaurs went from fast-running, ground-dwelling, bipedal, gold-blooded reptiles to warm-blooded, airborne, fully functioning birds in just 1 million years. Even by their own logic, it doesn't line up because it took nearly 3 to 4 million years to turn an ape into a human. And we're supposed to be 98% similar to them. See, things just don't line up, even in their own logic. What do you find if you break all of these fossils down? Well, Archaeopteryx, which is supposed to be the oldest, is a fully formed feathers. He is capable of flight. He has a bird's brain. The Natural History Museum proved that. And a bird's physiology. So it's a bird. Ileolarvus is a fully formed feathers, has capable of advanced flight, bird's brain and physiology. It's a bird. Caudipteryx has sub-feathers, just like many of the running birds we have today have sub-feathers, things like the emu or the rhea or the ostrich. Probably not capable of flight, just like these big running birds, but certainly had a bird's physiology, so it's a running bird. Proto-Archaeopteryx has well-developed veins, symmetrical feathers. It has a bird's physiology, hollow bones and stuff like that, and very long running legs. There's only ever been one found. It is a running bird. Sinosauropteryx really has no evidence of feathers at all, but has evidence of decaying collagen fibers. Now, you think about what you do if you spend too long in the bath. What happens to your fingers and your fingernails? You just get a bit wrinkly and horrible. Well, if you keep it in water, and you find this in drowned victims as well, particularly with creatures that have got scales, they begin to get a bit fuzzy. Now, if that then becomes fossilized like that, well, the argument was these fuzzy bits are feathers. Yet there's no evidence of any kind of veined feathers, but simply decaying collagen fibers. It's a fully functioning small dinosaur. There's no evidence of any feathers or any other things in any of the other creatures, including Velociraptor. And then the youngest one is, again, a fully formed bird. In other words, you start with a fully formed bird, you end with a fully formed bird, and there's no evidence of evolution in between. Interesting. Our final warning. Make sure you take off Darwin's glasses. Because if you do what Darwin says, which is observe change, call all change evolution, and therefore say you've proven evolution, you'll get to the wrong conclusion every time. So take off Darwin's glasses and start seeing things God's way. And remember where we started. Let this mind be in you that is also in Christ Jesus. If you start here, you can't go very wrong at all. Well, a reminder, creationresearch.net is the place to go. Questions and answers on there. Plenty of other resources. We're also developing our USA site as well, which should be up and running in the next day or two. There's plenty of resources out on the table to have a look as well, and I'll be around for questions and answers going forward. But thank you very much.